So here's an example of another differential equation. Again, we'll find this one to be separable, but it's about a second order chemical reaction. And I thought I would share this with a chemist I know who speaks backwards. Yeah, that's what I was going to do. I'll explain this. It ought to be just fine. Okay, well, I'll do my best to explain it, but I'll explain it forwards, although it might seem backwards to some. So, suppose we have A grams of chemical A and B grams of chemical B, and they're combining to form chemical C. And assume X of T is the amount of chemical C formed after T units of time. So, we got a pile of chemical A, we got a pile of chemical B, and some of this go together to make chemical C, and chemical C, I'm calling that X of T. And suppose chemical C is made up of M parts of chemical A and N parts of chemical B. They might not be in perfect ratio. Then the amounts of chemical A and chemical B that remain during the reaction are given by the original amount of chemical A minus M divided by M plus N, which is the ratio of chemical A that's already been changed, times X. And B, the original amount of chemical B, minus N over M plus N, which is the percent of X that's been made up of the changed B. Do you get what this is, N over M plus N? M over N plus N? This is the percent of changed A in the makeup of X. Okay. So this has already been changed from A into X. I don't know if that helps or not, but here we go. Logically, the speed of the reaction is jointly proportional to the amounts of chemical A and chemical B that remain. So dx dt is proportional to A minus M over M plus Nx times B minus N over M plus Nx. But let's keep these numbers a little bit simpler. Let's call it the change in chemical C is proportional to alpha minus X times beta minus X. That's ultimately what we're after here. How do you solve this equation? So, chemicals A and B are combining to form chemical C. The rate of change is jointly proportional to the remaining amounts of chemical A and chemical B. Initially, there are 100 grams of chemical A and 50 grams of chemical B, and for each gram of B, 2 grams of A are used. It is observed that 10 grams of C is formed after 5 minutes have elapsed. How much is formed after 20 minutes have elapsed? So, now we have an initial value problem. And it says how much of C can be formed over a long period, we'll get to that. How much of A and B remain after a long time, we'll get to that also. Okay, here's the story. We must solve dx dt equals K times A minus M over M plus Nx times B minus N over M plus Nx, but really it's this equation. It's just, you know, the numbers are dressed up a little bit. The K will take care of any other problems we have. So we're given value of A at 100, B at 50, M over N plus N is 100 over 100 plus 50, so 100 over 150, which is 2/3. N over N plus N, that ratio is 1/3, because it's 50 over 100 plus 50. And so the equation is K times 100 minus 2/3 X times 50 minus 1/3 X, or more simply, and with, well, this is a different K, but all we had to do is take our other K and multiply by stuff, so we could get, I guess, multiply by 3/2 this expression, and so to make this one 2/3 of that K, and multiply this one by 3, see, to get this. So that means this one will be multiplied by an extra third, so now we got 2/9 of the original K is this K, but remember, this is just a constant of proportion, so this is just another K. So, here's our separated equation. dx dt equals, or sorry, well, it's actually dx dt equals k times 150 minus x, that quantity squared, so dx over 150 minus x squared equals k dt. Integrating on both sides, we got positive 1 over 150 minus x. Now I want you to take a minute about that one. If you integrate u to the negative 2, you get negative u to the negative 1, but the negative takes care of itself because the derivative of the inside function is also negative 1, so those negatives cancel out. We just get 1 over 150 minus x equals kt plus c. And we also get the initial condition, there's no chemical C in the beginning. And that forces our C, this C, to be 1 over 150 time out on that one. If this is 0, we got 1 over 150 minus x equals C. So that means 150 minus, oh wait a minute, x is 0, so 1 over 150, okay, duh, 1 over 150 equals C, and that's perfect. So here is our equation. And we can invert both sides, and in that case we'd have 150 minus x equals 1 over kt plus 150, right? Just take this whole equation, stand on your head and look at it, it'll look like that. Simplifying the right hand side a little bit, we can multiply by 150 over 150, which is of course just 1, so we get 150 minus x equals 150 over 150 kt plus 1. And solving for x, we're almost there. All we have to do is subtract the 150 and then multiply both sides by negative 1. So x equals 150 minus sorry, I didn't like the way that was looking there. 150 minus 150 over 150 kt plus 1. We now use the fact we knew after 5 minutes there was 10 grams of compound C formed after 5 minutes. And so that should give us the ability to find K, so let's see if it does. We put in 10 here, and T is 5, so 10 equals 150 minus 150 over 750K plus 1. And let's see, subtract 140 from both sides and change, or actually subtract 150 from both sides and change the signs of both sides. We got 140 equals 150 over 750K plus 1, or 14/15 equals 1 over 750K plus 1, or 15/14 equals 750K plus 1. And finally, K equals 1 divided by 750 times 14. So we've got the complete solution. X equals 150 minus 150 over 150 over 750 times 14 times T plus 1. Simplifying still further, multiplying by this denominator here, we got 150 minus 150 times 750 times 14 over 150 plus 750 times 150T plus 750 plus 14. Finally, cancel out the 150s. Hallelujah. X equals 150 minus, this 150, this 150, and this 150 out of that cancel, leaving us a 70. So we got a model. And the graph is shown here. Pay no attention to what happens in the negative side, but I thought you at least want to see the entire graph, but that part of it has little meaning. Tricky problem. Don't give up. The assignment isn't terribly long. Each problem will take some time and will require some thought. And like these, lots of manipulation. But I know you're up for it.
Yes.
I knew you were.
Yes.
All right.